So let's get started. Again, sorry about that. My camera battery died. I should have seen that coming, and I didn't. But you know, mistakes happen. So anyway, we'll probably we'll split this up into 2 videos, I guess. So we're talking about magnets, and basically the problem was, I'll just resume where I left off without explanation. And if you want to know what I'm talking about, watch part 1 of this video. This is part 2. So here we go. I'm trying to show you. So if we have this tilted, right, and I have this magnet spinning around, there's a little bit of attraction, but not enough. So I have to bring it really close. I basically have to touch the magnet, and then if there's any vibration at all, it just drops. So I couldn't use magnets, right? So this was out, but this is still a work of art. I will probably use this in something else, but for now, it'll go in the recycle later bin. So I have a collection of assemblies that I can't use for the thing that I intended to use it for, but I want to use it for another thing later, and I don't know what that thing is yet. But I mean, I've literally a whole box of contraptions, and so I'll put this in there. I'm a little bit proud of this thing. It's pretty cool. Anyway, so let's talk about what did work. If you're wondering what this is, it's a micromotor that I took apart because it doesn't work anymore. So why not take apart the electronics that don't work anymore? Troubleshoot them, fix them if you can, and if you can't, learn everything about them you can. I'll shoot a video about that and how to break it down and what's involved in that and why these things break all the time. So that'll be a different video. So we're still talking about the subreflector system and the pointing system and the cone selector, whatever you want to call it. I just call it the subreflector, even though the subreflector is technically just the dish. But anyway, cone selector, whatever you want to call it. So I realized what I needed to do, because this still used a concentrically constrained dish, right? So in other words, the dish was still constrained to a joint in the middle. What I needed to, and I had floating joints with the magnets. What I needed to do instead was have a floating dish and fixed joints. And this is what I ended up doing. I built this. This is one of those triple axle hubs with the perpendicular hubs and then an axle and pin joining lift arm, right? And the idea was I mount this on a rod or an axle. I use those terms interchangeably, but I mount it on an axle. The axle doesn't spin, but something else spins, and it somehow lifts these. It doesn't have to be this part exactly, but something lifts these levers, you know, one at a time, and then drops it, and then lifts the next one, and then drops it, and then lifts this one, and then drops it, and picks up the first one again. And as it's spinning around, right? And then you have ball joint axles mounted to it, which was the right idea. And I ended up with this instead. So I actually ended up with something that looks more like, wait a minute. Ooh, I'm gonna have to replace that part. It's got a crack in it. Right there, across the part. But anyway. It's also old light gray, it's not light bluish gray. So it is an older part. Oh, it's the wrong side. Oh, well, I can just flip it over. Okay, so I built this, and the idea was I stick on one of those 6-length ball socket axles, right? And this is the new type that you can mount the ball from either direction. Oh, well, or you can do that. That's going too far, but anyway. I did not realize you could do that. That is pretty dope. I'm gonna have to remember that one. Anyway, so ball and socket joint. You have 3 of these, and it's floating. And then I just mount the dish to this, and now this dish is floating. Because there's 3 of them, I can push one down and the other 2 up. And as they are moved by cams or some other lever mechanism rotating in a circle, it is pushed up and down, which moves this, in theory, in a smooth circular wobbly pattern, right? Without rotating it. Well, great. So I did that, but I discovered when I did that, oops, that it was too close because they're in line. It was too close. It was this was sliding against this frame. And so what I ended up having to do was bring this out one stud. And the way I did that was simply by doing this. And you might say, well, wait a minute, that's actually further in, not further out. It's all about the angles. Because on center, if this is center, right, the ball would normally be here, and now it's out here. So it is actually pushed out one stud. I don't care how far outward it is in relation to this direction. I care about this direction. So I did that, and that turned out to be the ticket, right? So now it's rotated out to a spot that it can be, right? Okay. And originally I had lift arms attached to these spur gears that rotated around. And then I had this mounted, instead of the pin version of the ball joint, I had the axle version, like on this end, on the end of a cam. The problem was when it was spinning around over here, it was hitting these. I can't tell you how many times I've been wanting to cut these. Yes, literally cut that right off. Because I constantly use them for this worm gear application where I'm mounting them either this way or this way, the other way. I usually mount it the other way and mount the worm gear here, not on the inside. This would be the first time I've ever tried it the other direction, and it worked great. So I changed it to mounting it here, which worked. It worked great. you can see even on this one, it doesn't touch the frame at all. It gets close, but it does not touch it. And it doesn't touch the worm gear. Now, another reason this works is I actually offset the spur gears a half stud. Yeah. So that I could fit 3 around instead of just 2. This might be the coolest screw drive or worm drive gearbox I have ever built. It is so cool. So here's the idea. See how 2 come up and 1 go down? Let me try hanging it this way so you can see a little bit better. Okay, so now I think you get the idea. So now I join these together. Where did I throw that? Oh, there it is. It's blending in. Okay. So, and I make sure that the balls are facing the same direction. This black one here and the gray one here. Right? Then I connect the next one. And then I connect that one, right? Okay. Now, you see what it's doing? And this only works because it's not joined in the center anymore. It's only joined at the outside 3 points. Now, why does it spin the cams in such a way that only one of them is, that basically they're offset 120 degrees? How did I do that? Well, the secret is in the number of teeth on the gears. So, something to research in your own time is gear ratios, but for now, a simple explanation. A worm gear is like 1 tooth, and then these spur gears are 24 tooth. Well, 24 is divisible by 3 exactly, and it yields 8. So what I did was I just offset, this is at tooth 0, say, this is at tooth 8, and then this is at tooth 16. 0 is also 24, right? So rotated 8 teeth, ding, 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 ding. 8 teeth around from the center of the, from the center of the screw. 8 teeth one direction. From the center of the screw, 16 teeth the same direction. Same screw, 24 teeth from the same direction. Okay, so, and direction is important. I accidentally turned one backwards, and it still worked. It just didn't work in the correct, it was funky. It wasn't. So in other words, if I switch up the gears by mistake, it doesn't break. It still works. Which means this is tunable, which is really important because in actuality, the center of the screw, the way these teeth mesh inside, is not, it's not going to be the same on all 3 sides because it's helically wrapped, that screw. And so as it's turning, that groove moves in a circle around that gear. So the same groove here for this gear is not, it is the same groove, but it's in a different place here. It's slightly upward, and then it's slightly upward. So I had to kind of like go a little bit up or down or whatever. But it's tunable, and it works from any direction that I so choose to mount this. Now one of the problems or one of the issues that arose was this is allowed to wobble too much, and it's allowed to twist, which was a definite no-no. So what I did is I made these axles longer, and then I took this cam, or this handle thing, and I put that here. Now that doesn't keep it from doing this, but it keeps it from doing this so much. And now when I put 3 of them on, I'm sorry, other way. Like that. It's a lot, well, it's a little bit less than it was. And it guides it in the channels. Right? So that's how I built that. I'm going to split these up into the next videos. So next week I'll tell you about how I built the drive for this with the motor, and which motor I selected for the job. And I have a host of motors available to me, and we'll talk about that in a later video. So watch for that next week. If you enjoyed it, please give the video a like, a thumbs up, comment what you thought of it. What did you take away from this the most? What do you think you're gonna apply to your creations? I would love to know if you're wanting to build this. I'm not going to produce instruction manuals, but I might, if there's enough interest generated, and you're always free to ask in the comments, I might do a video that breaks this down even further to reverse engineer it and help you build your own. I would love to see many of these on the internet. That would be so cool to me, to see my model being used in other people's creations. Just give Gears and Bricks a shout out when you do so, and would appreciate that. And let me know what content you'd like to see in future videos. And subscribe if you haven't already. If you like what you're seeing so far, there's gonna be a lot more of this coming soon and every week. So just stay tuned. Thank you guys so much for watching. I'm Gears, and hope you enjoyed this video. Keep bricking, keep building, keep making, and have fun. Have a good weekend.